Math 8, welcome back. We're starting a new chapter. It's chapter 7 in your workbook. It's on area, volume, and surface area. So I'm hoping those words sound somewhat familiar to you. Today what we're going to do is we're going to review area. We'll do that for a couple days, and then we'll move on to surface area and volume, which I think you've probably done a little bit, but that's where it gets a little bit tougher. We better get right into it, otherwise this is going to be a long video. So here we go. What is area? That's all we're going to focus on today, what area is. So area refers to two-dimensional shapes, like flat shapes, right? If we're talking about area, you can't be looking at three-dimensional shapes like cubes and things like that. That would be surface area or volume. If you're talking about area, you're talking about a flat surface, and what you want to know is how much surface does it cover, right? Like for example, I have this blue rectangle right here, right? And it covers a certain amount of my white screen. And the amount of the white screen that it covers, that's its area. So for example, if I make this rectangle smaller here, obviously it covers less of the white screen, and obviously it has a smaller area. If I make this rectangle very, very big, its area is getting bigger and bigger and bigger because it's covering, I think I just changed the shape, whoops. It's covering more of the white surface. So the amount of surface that a two-dimensional shape covers is called its area. All right, so we got some shapes here that we want to look at, some flat shapes. So let's start with, I'll come back to the first one. Let's start with our friendly rectangle. You know what that looks like. Looks like this, right? So do you know what the formula is for a rectangle? Area equals length times width. Or of course, we're just going to do it a little bit faster. We're going to say area equals L times W. Now, some people don't use that formula. They actually use area equals B times H. You know what that stands for? Base and height. I'm okay with that. If you do it that way, you would label this B and this H. Or if you're going to go with the length and width, you would label what? Here's a big argument. Apparently in some countries, like European countries or something, I've been told by kids that the shorter side is the width or something like this. But they really don't have in North America, as far as I know, whether you call this length and this width, or if you call this width and this length, it really doesn't make a difference. Both work, okay? So basically you're just going to take those two sides, the two dimensions, and you're going to multiply them together. So I guess I'll do this is I'm going to do examples as we go along. So here's our rectangle over here. It's 8 meters by 5 meters, and I want to know what the area of this is. So I don't know, I could do it right in here. I guess I'll do it right here. Area equals, remember what the formula is? Length times width, or base times height. So base is here, there's no number. Well, obviously it's the same as this. So whether you use base or length, you know it's 8 times height or width, 5. You get 8 times 5. So the area is 40. 40 what? It's actually not 40 meters. It's 40 meters squared. Do you know why it's meters squared? That's because you could fit, see how this is 8 across and 5 down? Oh, it's going to be so hard for me to draw. 1, 2, 3, 4, 5, 6, 7, 8. You could fit 8 across and 5 down. 1, 2, 3, 4, 5. It's a terrible drawing. And you wouldn't even need to fill in the rest. If it's 8 this way and 5 that way, you know it's 8 times 5, there's 40, right? If I filled them all in, there would be 40. I'm not going to do it. And each one of these is a meter by a meter. Each one of them is 1 meter squared. And how many does it take to fill in the whole thing? It takes 40 of those things. So you have 40 meters squared. 40 of these little squares, each one of which is a meter squared, are needed to fill in the space here of this rectangle. So that's your first answer, 40 meters squared. Oh gosh, let's move. This is going to take way too long. So we've got this. The next shape we're going to do is our square. You know what that looks like. It looks like this. So you could use the exact same formula if you wanted to. You could use length times width again, and it will work. And to tell the truth, I think that's what most people do, myself included. But if you want to, you can also think of this as this side is S. Now wait a minute. This is a square. What do you know about all the sides in a square? They're the same. So if this is side, if this is S, then this is also S. Okay, well, what would the formula then be? The formula would be area equals length times width, or S times S. S times S. What's a faster way of saying S times S? S squared. So this is another way of writing the formula. Area equals side squared. But again, to tell the truth, what most people do, they take square and rectangle, they take the same formula, the area equals length times width, and there's nothing wrong with that. So let's take a look at our square. It is right down here. I'll do it in green. So we want to know the area of this. So if you want, you could go side squared. Well, there's only one side, which is 9, so it equals 9 squared, and 9 squared is 81. Or the other way you could do it is you could say area equals length times width. So area equals 9 times, how much is this? You see these tick marks? That means they're all the same. That's how you know it's a square. So if this is 9, then this is also 9. So that's why you could go 9 times 9, and 9 times 9 is 81. It doesn't matter which way you do it, you're getting 81. 81 what? Not 81 with no units, that would be bad. Not 81 just millimeters. It's going to be 81 millimeters squared. Always, always, always with area, it's always going to be squared. So we've done square and rectangle. Moving on. Next comes the triangle. Now, the problem with triangle is we got to look at 3 cases here. We got to look at an obtuse triangle with an angle bigger than 90 degrees, a right triangle. I guess to show it's a right triangle, I should put my little square in the corner, and an acute triangle where all the angles are less than 90 degrees. So the formula for all of them is the same. The formula is area equals base times height divided by 2. Or if you want the short form, we just put base times height divided by 2. Or some other times you'll see people write this, 1/2 base times height. I prefer this one. I like this more than, people get freaked out by the fraction. So even though it means the same thing, I prefer this one right here. By the way, why is it base times height divided by 2? Well, don't draw this if you're taking notes, but if I was to make this shape, do you see that you have a rectangle here? And you could get the formula by going base times height, and that would give you the area of this whole thing. But wait a minute. Base times height gives you the area of the whole thing. We don't want the whole thing. How much of that do we actually want if we just want the triangle? We want half of it. So that's why you would divide by 2. Okay? Or that's why you'd go 1/2 times. So that is the reason why it's 1/2 base times height. All right, so with the right triangle, it's really no problem. Here's your base. Here's your height. You multiply base times height. You divide it by 2, and you're done. For this one, the base is pretty easy to see. The base is right here. Now, where's the height? This is not the height. The height has to be from the highest point straight down. So your height is from the highest point straight down. You can't even see that, can you? So this is the height right here. How about this one? The base is, well, let's start with the height actually. The height is from the highest point straight down. Many people think this is the height. It's not. It has to be straight down. So you have to go straight down for the height. But how far down do we go? You go down until you hit this point here, the continuation of the base. All right, so this is a bit confusing. The height is this distance here, from the tip down to here. Where's the base? It's not from here all the way to there. The base is this amount right there. There, I changed colors. Maybe that's easier to understand. Height, base is only from here to here. All right, let's do our examples to make sure we understand this. So let's start with the easiest one, which is this one right here. Now, for some of these questions, I've given you more information than you need, and in some of these questions, these examples, I haven't given you enough. So what about this one here? More or not enough? Well, the formula for a triangle is area equals base times height divided by 2. Do you know the base of this triangle? Sure you do. The base is 4. So we can put 4 there. Do we know the height of this? Yes, we do. Which one's the height? This is the height, the 3. You do not need this number here. It's totally not necessary to get area. So 4 times 3 and then divided by 2. So that's 12 divided by 2. So the area is 6. 6 what? 6 feet? No, 6 feet squared is your answer. Okay, let's go to this question next, the acute triangle. So again, it's a triangle. Area equals base times height divided by 2. Do we know the base? Sure we do. The base is 6. Now, this is an equilateral triangle. All the sides are the same. So this is 6 and this is 6 as well. That's what the tick marks tell us. So does that mean that the height is 6? No, the height is not 6. How come? Because the height is from the highest point straight down. In other words, I haven't given you enough information in this question yet. Let's say, just to make it easy, let's say that that amount right there is 5 centimeters, of course. So then we have our base of 6, and we have our height of 5, and then for a triangle, you always divide by 2. So you get 30 divided by 2, you get 15 centimeters, and it's an area question, so it's going to be squared. And our obtuse triangle. So you have too much information, and you also don't have enough information. Let's see what I mean. Formula, base times height divided by 2. Notice how I'm doing this for every question. I'm writing the formula, I'm showing the work, I'm putting my answer with the units. This is what I expect of you. All right, so base. Do we know the base of this triangle? We do. The base is 10. Do we know the height of this triangle? We do not. Remember, you have to go from the highest point straight down. So I'm actually going to get rid of this 11. We don't need it. I'm going to get rid of this 20. We don't need it. What we do need to know is how high is this distance, how much is this distance, straight down to the continuation of there. By the way, do you know what kind of angle that makes here? It makes a right angle. So the 10 meters is still from here to here, just like we already had. That's the base. And our height is this distance. I haven't told it to you yet. Let's say that it is, I don't know, 4 meters right there, from there to there. I'm just making it up. So then it would be 10 times 4 divided by 2. So it would be 40 divided by 2. You wouldn't have to show me all these steps. I know you could probably do these in one step, but show me a little bit of work. And what are we talking about here? Meters, so it'd be meters squared. Okay, time for a new shape. Okay, next let's go with the parallelogram. Looks like this, right? Kind of looks like a rectangle that's flopped over. The lazy rectangle. If all sides are the same, by the way, what do we call that? If it looks like this, where all the sides are the same length, you know what that's called? It's called a rhombus. Rhombus. I'm going to erase this in a second, but just so you know, it's called a rhombus, and it's a type of parallelogram, a special parallelogram where all sides are the same. The formula is the same for a rhombus as it is for a parallelogram. So what is the formula for a parallelogram and for a rhombus? The area is base times height. The base is pretty easy again. The base is just down here, or if you're doing the rhombus, right here. Again, I'm erasing this in a second. The height is not here. The height is from the highest point. Well, that's anywhere along here, and then straight down. So you could go from here to here. You could go from here to here, here to here, here to here. It doesn't matter. These are all the same. You could even go from here. This would be weird, but you could go from here down to there. That also works, but I wouldn't do that if I were you. I'd do one of the ones inside. Maybe right here. Doesn't really make a difference, but I'll draw mine right there. So it makes a right angle, and so this is my height. All right, so you just multiply those two numbers together. Let's show you. Here's my parallelogram right here. Do you have enough information? No, you do not. You need to go base times height. I know we usually think of base as being at the bottom here, but look, that amount there is exactly the same as that amount there. So you know the base is 12. Now you need your height. That is not the height. You don't need that number. What you need is from the highest point straight down. And I haven't given that to you. Let's say that that amount is 8 meters. So you got base of 12, height is 8. 12 times 8, uh-oh, hard one. You got it, 96. 96 what? Meters squared. Okay, just before I erase this, remember with the rhombus, it would also be base times height would be from the highest point straight down. So this would be your height, for example, right there. But I'm getting rid of that because now it's time to do the trapezoid. Ooh, this one's a little bit tricky. So there's a few things you need to label in this one. You have these two parallel sides, right? Like train tracks, they're equal distance apart at all times. You're going to call one of those A, and you're going to call one of those B. The other thing you need to know is the height. Again, the height is not this. The height is not this. The height is, guess what it is? From the highest point straight down, just like everything else we've done with height. So this is your height. Ready for the formula? It's pretty crazy. Area equals side A plus side B. You multiply that times the height, and then you divide it all by 2. Who wants to write that every time? Let's just write A equals A plus B times the height divided by 2. Let's give you an example. Here's our trapezoid. Do we have everything we need? Not even close. What was I doing in this question? You need the top, you need the bottom. Let's say this was 6 centimeters. Again, just making up questions as I go along here. You don't even need this one, do you? That's not the height. The height is from the highest point straight down. And let's say that that's also 6. Why not? That could be the same amount. So now we're ready to get our answer. The formula for trapezoid, as we just saw, is A plus B times H divided by 2. So what's A? Well, A and B are the two parallel ones. It doesn't matter which ones you call A and which one you call B, as long as you use them both. So 4 and 6 are my A and B. 4 plus 6, or 6 plus 4, it doesn't make a difference. Times the height. How much is the height? The height is 6. So we're going to multiply by 6, then we're going to divide by 2. So 4 plus 6 is 10. Then we're going to multiply that by 6 and divide by 2. 10 times 6 is 60, divide by 2. I know you wouldn't show all this work, but what the heck. So you get 30 centimeters squared, always squared. We only have one shape to go. It is a beautiful circle. There it is. Do you know what the formula is for a circle? The area of a circle is pi times radius squared. Oh my. So area equals pi r squared is your formula. So there's a few things we need to look at here. Pi, have we talked about that number in this course? I believe we have. It's an irrational number. It is 3.141 blah blah blah, goes on and on. So you can use the number 3.14, or if you want a more exact answer, your calculator should have a pi button, and why not plug that into your calculator to get a more exact answer? The r is the radius. Do you know how much the radius is? The radius is from the center of the circle to anywhere you want on the outside of the circle, right? Whether I draw it here, that's a radius, or I draw it this distance, that's a radius, or here, that's a radius. Doesn't matter which way you draw it. Now, for some reason, we tend to always, when we're drawing little pictures of it, draw it straight out like that. But you don't have to. You certainly do not have to draw it this way. So this is your radius right there. And what you're going to do is you're going to square the radius and then multiply by pi. It would almost be more useful if we wrote it like this, r squared times pi. Because, be careful, because of bed mass, you actually have to square the r before you multiply by pi. If you go pi times r, get that answer, and then square it all, you're going to get it wrong. You need to do the squaring part first and then multiply by pi. Okay, last example, thank goodness. Here it is right up here. So remember, our formula is area equals pi times radius squared. So area equals pi times 10 squared? No. This is not a radius. This is the whole way across the circle. That's called the diameter when it's the whole way across the circle. Well, if the diameter is 10, how do you get the radius? Well, the radius is only halfway across the circle. So if the whole way across is 10, then the radius must be half as much. It must be 5. That's the radius right there. So you actually want to have pi times 5 squared. Okay, let's do the radius squared first. 5 squared is 25. So you get 5 squared is 25, and you still have this pi. This is actually the best answer of all. Once you get to like grade 11 and 12, that's the way we're going to want you to leave your answer, because that's exact. As soon as you actually multiply by 3.14, your answer is not quite as exact, because remember, pi actually isn't just 3.14. Pi is 3.141592653589793, and actually keeps going. How long does it go? Forever. So, it doesn't matter how many numbers you plug into your calculator, you're not getting an exact answer as soon as you put 3.14 or whatever. So if you want an exact answer, you'd go 25 pi centimeters squared. That's fine. But I would imagine that most of you, and that's totally okay, are going to go 25 times the 3.14. And if you do that, you will get 78.5 centimeters squared. Or let's say you're, good student and you remembered what I said about not putting 3.14, but putting 25 times the pi button, which you can find on your calculator, you would actually get area equals 78.5398, maybe you want to do it to 2 decimal places, and you could have 78.54 centimeters squared. So any of these three answers are fine. This is the most exact answer here, but in grade 8 you're not expected to do it that way. This is probably a preferable answer, the last one, so I guess that's the one I'll circle. But the one before that is obviously good as well. You're almost exactly the same thing. And if we were doing it to 1 decimal place, it would be exactly the same thing. So those are all the shapes that you need to know the area of. We're going to give you some practice doing that today. Here's your assignment. It's assignment number 10. It's going to be in your workbook. It is in your workbook. I have posted the workbook places under Files in Math 9 in Teams. So if you go to Teams and then look for Math 9 and then go to Files, you'll find a file that's called something like workbook, and then it says like area, volume, surface area. So if you don't have your book at home, look for that and you'll be able to get the workbook. Anyway, your assignment for assignment number 10 is workbook page 171. You're going to do all of that question, which is number 1, and then you're going to skip to page 174 and you're going to do number 4. Now, you're going to see in all these questions, they want you to answer finding the area, which I definitely want you to do, and they also ask you to find the perimeter. Do you know what perimeter is? I really don't want to make this video any longer, but perimeter is the distance around the outside of something. So for example, if you had a square, right, there's our tick marks to show it's a square, and if I told you one side here was 5 centimeters, to get area you'd go 5 times 5 is 25. We just learned that. But if you want to know perimeter, it would be the distance all the way around the outside. 5 plus another 5 plus another 5 plus another 5. Well, that's 20. But I don't want you to do the perimeter today. You're doing enough with the area. So these are the questions you're going to do, just area. Don't do all the perimeter. I mean, if you want to, go for it. But I'm only interested in you doing the area questions. This will be due on Monday, May 18th at 3 o'clock p.m. Have a great week. Let me know if you have any questions. Bye.